Okay, let's continue on with the muscular system, and in this video we'll discuss the characteristics of skeletal muscle. Okay, so let's look at the characteristics of skeletal muscle. Skeletal muscle has 5 basic characteristics, so let's just write these out here. Characteristics of skeletal muscle, okay? And there's going to be 5 basic characteristics. The first one is it's excitable. Okay, by excitable, what I mean is that the muscle or the muscle cells have the ability to respond to a stimulus. Now that stimulus can either be chemical in nature, it can be a stretch. So if you're stretching that muscle, it can respond to that. And we'll get into more specifics of this, but generally speaking, how it responds is we're changing the resting membrane potential. So if you go back to the cell, the basic cell, the cell has a plasma membrane. That's the outer membrane of a cell. And you have certain ions on one side of the cell, on the exterior side, and then you have the intracellular ions. So if you stimulate the cell, we are altering the resting membrane potential. Now, you'll go into this much more detail into the physiology side of this. In the anatomy side of the course, we'll briefly touch on it, but we won't get into the specifics. But suffice it to say, you are changing the resting membrane potential, which allows those ions to move across the plasma membrane easier. Okay, that's essentially what excitable is referring to. The second one that we're going to be looking at is it's conductive. So when the cell is stimulated, okay, either a chemical or physical, like a stretch, it can conduct a charge, a current, if you will, across the plasma membrane. So it propagates across the surface of that membrane, and that conductivity can then move into the cell. And when we look at the video where we're going to go the microscopic anatomy of a cell, we're going to go through the specifics of how that electrical current can propagate to the internal structures of a cell. But for our purposes, conductivity refers to the ability to conduct the electrical charge across the plasma membrane. So it propagates across the plasma membrane, and it can conduct itself to the inner structures or the inner portions of the cell. A third one is going to be it's contractile. Okay, so it has contractility, and as with any other cell, you have various proteins within the cell. For a muscle cell, which is going to be known as a muscle fiber, you are going to have various contractile proteins that are oriented in a way where they're in a structure like this, okay, where they're kind of over top of each other, and the contractile portion of this allows for those plasma proteins to slide across each other. And when they slide across each other, that shortens the muscle, okay? So that, or shortens, contracts the muscle. So as they slide across, and again, we're going to get into this in much more detail in a future video, but just for now, know that these plasma proteins in the muscle cell have the ability to contract, which means they're sliding over each other, which causes it to shorten, and that allows for the contractile portion. Now, when we're looking at these three, the first three here, basically are taken together. So it's excitable. It means the cell can respond to a stimulus, okay? And in this case, what we're looking at is if I look at a skeletal muscle, my brain starts an impulse that says, okay, contract your biceps, and that causes this muscle to contract. I am sending an impulse down the nervous system to this muscle. That nerve has to communicate with that muscle somehow. And it communicates through a chemical stimulus. And specifically, that chemical is acetylcholine. We'll get into this in another video. That acetylcholine alters the resting membrane potential, which allows ions to cross the membrane, which allows for the conductive charge to propagate over the plasma membrane and into the cell, allowing the contractile proteins to slide over each other. That allows for the muscle contraction. So those three components are often taken together on this one. Two more characteristics of skeletal muscle. One is it's extensible. Basically means it can be stretched. So everybody's kind of done this. If you start to exercise, and they always say do warm-up stretches, okay? So you're stretching a muscle beyond its standard normal length, okay? So as I'm stretching a muscle, those muscle fibers can be pulled apart, not just contract, but I'm pulling those proteins. Instead of sliding this way, I'm stretching it where they're lengthening the muscle, okay? So that's extensible. And the last one that we're going to be looking at here is its elasticity. So it's elastic. And elasticity is referring to the ability of the muscle to go back to its original length, okay? Just like your elastic waistband around Thanksgiving, okay? It stretches, but as the food moves past the stomach and so forth, that elasticity has the ability to come back down to its original length. So those are the 5 basic characteristics of skeletal muscle. You have it's excitable, it's conductive, we have the contractile ability. Those first 3 come together. It's also extensible, meaning it can stretch beyond its starting length, and it's also elastic, which allows it to go back to its normal length. Whether I stretch it, it can go back to its rather original length, or I can contract it, and then once that muscle's relaxed, it goes back to its original length. So the elastic portion is just not associated with the stretching, but it's also contraction, and then it would come back to its normal shape. The next video, what we're going to do, we're going to look at the gross anatomy of skeletal muscle. See you then.